Hi, I'm Tyler Potts, and I'm a data scientist with a background in neuroscience. And today I want to talk about my project that used sentiment analysis of Amazon text reviews. So the goal of this project was to create a model that can predict both good and bad sentiment based on a text review. And the reason that I wanted to do this project is because there's many organizations out there that have reviews of their products or services, but they haven't implemented an explicit star rating or good-bad rating for the text review. And so what this can do is it can go through all of those raw text files and spit out a prediction on whether the text itself is a good or a bad sentiment. So how it works. I started with the Amazon reviews dataset, which is all of the text reviews for Amazon, stored on this S3 bucket. I then processed that bucket of data with Spark, which is a distributed computing network. And once it was processed, it went back in the S3, and that data then was piped to a GPU instance where my neural network was trained. So data analysis. When I first got my hands on the data set, I wanted to figure out what the data looked like. And so when I analyzed a subset of the data and looked at the distribution of star ratings, it's clear that there's a large volume of ratings that are on 5 and very few in comparison in the 1, 2, and 3. So what I did is I decided to split the data into good and bad. And the way I define that is 4 or 5 stars is good, 1 and 2 stars is bad, and 3 were filtered out because I considered them too ambiguous for the network. And as you can see on the right, once this was processed, we ended with roughly 120 million good reviews and 20 million bad reviews, which follows that same pattern of seeing good reviews overrepresented. So as far as Spark processing was concerned, I built a network of 20 connected virtual computers, and they all worked on this process to turn those text files into representations of numbers. So each word was represented by a single number, and in that manner it could be input into the neural network for further training. And as you can see here, this is just a small snippet of the progress of when it was processing, and each one of those blue rectangles is a node working on that process. So neural network training and the results of it. So once I had the data in a form that could be trained, or a form that could train a network, I built one. And so the input for this network was 78,000 nodes. Each node was representing a unique word in the data set. And that layer was fed into another layer of 2,000, and then 150, and finally a single output layer, which would give us a probability of whether it was in a good review or a bad review. And as you can see, the F1 score was 0.962 out of a scale of 1. So that shows that this is a very effective model. This ROC curve here also shows that this could be applied to different business contexts. So if you are an organization where a negative review impacts you very highly, you can shift the boundary of what is classified as a negative review according to that probability, and in that manner it will be less likely to give you false negatives and false positives. So future steps. I want to investigate recurrent neural networks, because with recurrent neural networks you would be able to keep the structure of the text review instead of the current system where it's just represented by numbers and that structure is lost. I'd like to automate the deployment of this, as well as create an API call where you could feed it a text review and then get out a good, bad rating. This is my contact information. If you have any further questions, feel free to reach out to me. Thank you.